Hello, welcome everybody. In this small video, I'm going to explain how to bootstrap a development environment for scientific programming using the Miniforge Python distribution and Visual Studio Code. This video is intended for students and researchers who are new to Python. It is therefore very basic and introductory and covers the basic tools and some good practices. And first of all, apologies for the sound of my voice. I have a bit of a cold, and also there will be possible background noises from my neighbor who decided to do some renovation today. The first step is to install Miniforge. Miniforge is a free Python distribution that includes both the interpreter and all packages that are useful for scientific programming and also machine learning. Miniforge is available online as a standalone installer. The installer I'm going to select is the one for Windows, 64-bit machine, which is the version for my computer. I click on the link and the system begins to download the executable. We're going to see that Windows complains because this is a program and programs may contain viruses. So we will have to tell the operating system to preserve this file. A few seconds left. And now you see the warning. It's in Spanish, apologies, that's the language of my computer. And I will select in the right hand menu the option to keep the executable. Second warning, it's very persistent, but we open this menu and say that we want to keep it anyway. Okay, now we have the installer and it will be in the download page or the download folder of my computer. Let me close this and we are going to install Miniforge. Installation is very easy. We will click the default options. This is the license, it's a free software license. And I'm going to install it only for this account. This is an account without privileges, so this is the recommended way to do it because this way we cannot screw anything. So if any problem arises, we can simply delete Miniforge and we're done. The default installation place is within the folder of my user. We create a Miniforge 3 subfolder and everything will live there. The default options are fine and we are going to clean the installation a little bit afterwards. This takes a few seconds and it will unpack all the libraries that Miniforge needs to operate. This is going to be a bare bones environment. This is not like Anaconda that contains editors and other stuff that you may find useful. We do this because this way we can keep a self-contained, very minimal environment that is very reproducible. It also doesn't take so much space in the computer. We are finished. And now what we can do is to check that Miniforge is installed. I'm going to open the terminal. You can also use just a command line processor from Windows. And what we find is that there is a Miniforge directory full of software. It's not very large, and in particular Python is there. So we could in principle execute Python from there. However, this is not the recommended way to do that because the computer needs to know where your Miniforge installation is. So instead we are going to activate Miniforge using a package called Conda. This program is the one that is used for installing, removing packages, creating environments, and in particular I'm going to say now that we want to register Miniforge with the operating system. So in particular what thing it does is it creates this profile or updates it. We can see what it does. No, this one here. it has created a little bit of text within this file so that every time we open the terminal, it will check whether Miniforge is installed, and it will launch Conda. And this way Conda will be available for all terminals. If we exit now and we open the terminal, Conda is there. And we can activate the default environment. And now we have activated the environment in which Python lives, and we can simply type Python and it will be available for us. However, this is not the recommended way to work. The core environment should be kept minimal and should only contain the software that is needed to manage the installation of the packages. Every time you want to do a scientific programming project, you should do it in a separate environment that contains a copy of the Python interpreter plus only the libraries you need for that project. So the first thing we are going to do is to update the core environment, and then we are going to create a separate environment for working. So we are going to tell it to update our Python environment. This will look in the internet for all newest versions of the software that Conda requires to manage software packages and the Python installation itself. And it will replace the existing one in your computers with those ones. This also updates links to software repositories, whatever security keys are needed. So whenever you're going to create a new environment or install software in any other part of your computer regarding Python, you should perhaps have a look at updating your system. You see that in this case it found that there is a lot of packages that need update. They have changed since the times that the installer was made. There are not many, and they are mostly related to libraries to access the internet or libraries to manage the software database. So we say yes, and Miniforge will download all the packages in parallel, and it will decompress and install them in your computer. This can be a bit slow process if your internet connection is not very good. But in this case, because it's only the update of the core system, it doesn't take too much time. We're almost done. And it's unpacking all the software. And we're finished. There it is. Notice one thing is that the packages we have in your system don't include the latest version of Python. That's fine. That's the version that Miniforge needs to operate. We're going to keep it like that. We're going now to create a separate environment for our numerical simulation projects. I'm going to do it with the command conda create. The environment is going to be called Quantum because I like it. And we are only going to install the software that we need. In this case, Python, NumPy, SciPy, and Matplotlib. This is a very minimal installation. It contains the interpreter, a library for numerical programming, mostly around linear algebra, vectors, tensors, and so on, and a library which is called SciPy that extends the functionality of NumPy to include also sparse matrices, optimizers, integrators, solvers of differential equations, and Matplotlib, which is the standard for plotting in Python. I'm going to tell the system to install these packages, and these packages will require other packages, so this is going to be a little bit slower than before, especially the system has to analyze all this database of available software, and we will get a slightly longer list. Takes a little bit of time to compute which versions it needs for which packages. It's a very complicated optimization problem. And it's converging to a solution. There it is. Notice that there are many more packages than before, because now we are asking for things, for instance, like managing fonts for the plots, which are required by Matplotlib, the numerical libraries that we ask for require other libraries to operate. For instance, they require BLAS, which is the standard for solving linear algebra problems. Is going to use MKL, which is an Intel-based library for optimizing these computations in Intel-type CPUs. This is state-of-the-art. And there are other libraries, for instance, for databases and stuff like that. I'm going to click yes. We start downloading the packages. This takes a lot of time, so I'm going to pause the recording and resume whenever this is finished. We're almost finished. MKL is the largest library and the one that takes the longest to download. And once everything is downloaded, Miniforge will start unpacking the software. Everything is going to live in the same subdirectory of Miniforge 3. And right now it's not accessible because, well, we are in the base environment, but we can activate the new environment using this command, conda activate quantum. This changes the path in which Windows looks for programs, so that now it includes this directory, the directory quantum, within the Miniforge environment. We can check it by launching Python. Notice that Miniforge selected a newer version, stable newer version of Python, which is available for us, and we can import one of the libraries we call for, import by, and we can try to use it, for instance, to compute cosinus, and there it is. So the environment is available for us to run. The next thing will be to install an IDE, an editor, to develop more comfortably whatever software we want to do. As development environment, I recommend to use Visual Studio Code because it's quite accessible and it contains tools for almost all programming languages. So we will look for Visual Studio Code, and it's in this web page. This software is free and is available in many platforms. I'm going to download the version that it recommends for Windows. Click on it. Well, this is a description of the software, all it can do, but you will notice that the download begins immediately. Like before, because this software is produced by Microsoft, it will be signed with a security code that the operating system understands, and it will not complain when we try to install it. The download finished. It's available as before in the downloads folder of my computer. I'm going to use the installer to install the IDE. The options again are very simple. I accept the license. It's going to install in the default location within the user environment with the right name for the menu, and I don't have to touch anything else. Install, and the software will unpack all the files into my computer. And there it is. Okay. So it's opening some files I had already before. So I will launch Visual Studio Code again. And this should be more or less the first window you see when you launch Visual Studio Code for the first time. There will be options to create new files, open folders, and some recommendations of extensions. I'm going to start by creating a single file. And because this is the first time we use Visual Studio Code, it doesn't know any programming language. So I'm going to write down a new file with the name example.py. I'm going to save it in a temporary folder. There it is. So you notice that this is the first time it sees a .py file, and py is the extension for Python languages, Python programming language, and so it recognizes that there is an extension available that can handle this kind of source files. It recommends to install it. I'm going to do it. Installation doesn't take a long time. This will provide us with many options, including, for instance, the possibility to check the source code, to autocomplete function names or variable names. In general, it's a very comfortable environment once we have this. Let me close this installation. Now the system not only recognizes the programming language, which is here, but it also has detected that we have different Python environments. We're going to select the one that we use for programming, which is Quantum. Ignore the core environment base, and we're going to write a simple hello world program with one function. This is a function in Python that's going to execute a single statement. Printing a message on the screen, and this file will simply call this function. I'm going to save it. You can also use Ctrl S. And, well, don't show again. This is another extension to auto-format the file. I will explain it later on. But once it is saved, now we have the possibility of executing the file using our Python environment. So I click play, and what it does, it calls conda to activate our Quantum environment, and it outputs a hello world message, which is the result of executing this program. Now, this is very minimal and it's not a recommended way to work. What you should now do is to have a folder with your project and different source files. This is the next step we're going to take. So the next step will be to develop a very small project in a separate folder. This is an empty folder here. And I'm going to open Visual Code to work with this folder. Say open folder instead of opening a file. And I'm going to select this one. The difference from before is that now we have access to the whole folder and we can have multiple files and data and things to manipulate it. As an example, I'm going to repeat what we did before, creating a Python file with the right environment. Quantum is selected. This is our environment for executing these files and for testing the code. And we can save it and execute it. And as before, it works like a charm. I'm going to delete this terminal, and instead of having this simple example, I'm going to create another one that does our first graphical application, which is doing a plot. To do this plot, I'm going to use a NumPy, so I need to import the library first. It's typical to use a shorter name than this one, so we import NumPy as np, and I'm going to import also the graphical, the library to manage the plots, matplotlib. Notice that Visual Code offers me the possibility to complete names. I could simply select what is suggested me, and this is going to be abbreviated as well. So for the plot I need two vectors, and vectors of numbers, 101 numbers going from 0 to pi. Notice how it offers me information about the function that I'm going to use, such as where the first argument means, which is the start of the sequence, the start of the sequence, and how many points I'm going to use. An additional documentation I can check. This is very convenient. And I can execute another function to compute the cosinus of this previous vector. Together they make up for a very nice plot. And in order to show this plot in the screen, I will have to use the show statement, because otherwise the program will do nothing. And I save it and execute it. So notice two things. First is that my program is right now blocked. It's not doing anything. It's only showing the window of this cosinus function, and the program stopped exactly at the showed statement here. It will not continue until I click close here, and at that point the program continues execution and finishes. This is useful. I mean, you can do many programs in this form as Python scripts, which you can execute one time. But people nowadays are more used to working with notebooks, which are files that combine text and code. So we are going to create our first Jupyter notebook to do exactly the same thing as here. There are two ways we can do that. One would be to press Ctrl-Shift-P and create a notebook with this menu. I prefer to simply go here and create a file with the right extension. This is the extension for Jupyter Notebook files. When I click enter, two things happen. First is we have a new file, and second, Visual Code opens it with minimal content that has the Jupyter Notebook structure. So before we had source code made of lines of code, and now we have a Jupyter Notebook which combines boxes of different types that can contain code or text. For instance, I can create a text box with some title, and I can press Shift Enter to convert the markdown code into something that is more visually appealing. I can include more text. Shift Enter, and it's converted to, again, the right fonts. And here I can do an example. I could try to write down some small Python calculation and use the play button or Shift Enter to execute the cell. So we do that. Well, what happens? Well, we cannot execute this cell because in order to manage a notebook, we need to install an extension that controls the execution of arbitrary code. So we're going to follow Visual Code suggestion, and what it will do is it will download an extension for Visual Code from the internet, and as a next step it will ask us to select the execution environment that we need. In this case, As before, we are going to stick to Quantum, but this environment doesn't contain everything we need. In particular, it only contains Python, NumPy, SciPy, and Matplotlib, but it doesn't contain a kernel, piece of software that controls the communication between the Python interpreter and Visual Studio Code. So we are going to install it. This takes a while, not too much, but it has to use Conda to download all the packages for this environment. But these packages are going to be in the Quantum environment. They are not going to pollute the base environment. This is one of the reasons I like to work in separate environments for each project, because you end up installing a lot of software that you at the end want to erase after the project is finished. So checking the packages it needs to install. And unpackaging. There it is. And we're done. And once we are done, it launches the kernel, which launches a Python interpreter and produces the right output. So we're going to copy the code from here, here, and we're going to paste it here. This is a piece of cake. It's simply cut and paste, and we can execute the cell, and it does the same thing, but the difference is that now the plots are embedded in the notebook. This is nice because you can keep everything contained in a single file, such as explanations of how your code works, the code itself, and the output of the code.